32b, this function right here we will show this to not be homogeneous. Show that it is not homogeneous. That's better wording, yeah. Okay, so we'll look at a particular scalar, 3, and a particular 2-vector, 1, 2. And let me examine the value of f at 3 times 1, 2. That's 12. And then I'll examine the scalar times f of 1, 2. That's 3 times what f gives when you put in 1, 2. 1 plus 2 plus 3. And that's 18. I'm thinking, let's check it again. 3 plus 2 plus 1, that's 6. 6 times 3, that's 12 plus 6 is 12 plus 6 is 18. Whew. Okay, now this time I'm going to be a little bit more reasonable in how I draw my two vectors x and cx. I'm going to draw the first component on the horizontal axis, which you're more accustomed to than what I did in 32a. So x is 1, 2, and c times x is 3, 6. Okay, and let's see, what does x get taken to? F of 1, 2. F of 1, 2 is 1 plus 2 plus 3, which is 6. So over here I've ticked off 6, 12, and 18, and f of x is right there. That's 6. And in blue, cx is 3 times 1, 2. That's 3, 6. F of that is 12. So draw a blue line going off to 12. And that is f of cx. And I'll grab my black pen and put the parentheses that I forgot to put in. Okay, and then in red, the odd guy out, that is c times f of x. That right here, c times f of 1, 2. And that is 3 times this. So that goes all the way out to 18. A third vector then goes all the way out there, and that is c times f of x vector. And I think this is the clearest example yet where f of c times x is certainly not pictorially c times f of x. They sit in totally different places. And to wrap this up, I wrote, since for some particular 2-vector and scalar x, y, and c, namely 1, 2, and 3 respectively, f of cxy is not c times f of xy, f is not homogeneous. I hope these are making sense, and we will continue working up in complexity to 2-vector valued functions of 2 vectors. That is, we're going to take in 2 vectors and give out 2